Greetings Internet, I am Ken from the Computer Clan, and today we're going to talk about one of the big new features introduced with macOS High Sierra, APFS, also known as the Apple File System. And it is my goal to be able to explain the benefits to you as a potential consumer so you just understand the basics of what you need to know and I won't blow your brain up. But also I will try to satisfy that techie curiosity that some of you may have. So let's dive in. We're going to start with a brief explanation and a little bit of history here, and a quick explanation of APFS and some other things related to it. Then we're going to get into the benefits. This is the good stuff that the consumer wants to know. They want to know how it's going to make their lives better. We'll talk about that, but then we'll dive deeper and explain how those benefits actually work. We'll talk about what's going on under the hood. Then we'll talk about, quickly, some other features of APFS. Then I will address some frequently asked questions, and then do stick around until the end because I have some cool resources that will really help you if you decide to continue learning more about APFS or tech products in general. So first, what is a file system? Well, a file system manages how data is stored and retrieved on a storage medium, for example, a hard disk. So then, what is APFS, or the Apple File System? Well, APFS is a next-generation file system for Apple devices with loads of new features, and it replaces the predecessor, HFS Plus, and it scales from Apple Watch to the Mac Pro. So, that Apple Watch that's on your wrist, to the iPhone that's in your pocket, to the Mac Pro that's in your office, APFS actually runs on all of those devices. So now that begs the question, what is HFS Plus? Well, HFS Plus is actually the default file system on macOS 10 up until just recently with macOS High Sierra, released in 2017. HFS Plus was the successor to HFS, and this was actually introduced way back in 1985 with Macintosh System 2.x. HFS Plus was built on top of technology that is decades old. So what are the benefits? How will this make a typical consumer's life better, or anybody's life better when they use an Apple product, particularly a Mac? Well, APFS will help increase speed. It will help save space. It'll help save power. It'll be more power efficient on your hardware. It will help prevent crashes. And it will help back up data more efficiently. And theoretically, it could also be a lot more secure with some new encryption features, but at the current time of this presentation, I know Apple's kind of working out some bugs for that, so we'll ignore that for now. In a perfect world, APFS actually does have some new security and encryption features too. Back to the question, what is APFS? The short answer, it'll make your Apple device better. And honestly, most people probably won't notice it, but technology is at its peak performance. It's most powerful when it's most transparent. For most people, it's actually best that it's not noticeable. But I know there's people that are curious and people that want to learn more and understand how this works and what technologies actually make these benefits possible. And I admire that curiosity, I seriously do, and I love techies. So keep watching if you want to learn more. So, what makes the benefits possible? How does APFS work? Let's go deeper. So there's a lot of features in APFS, but I'm going to cover 4 key features that will explain more about how those benefits actually are possible. Space sharing, cloning, snapshots, and atomic safe save for document bundles. But anyway, let's talk about that first feature, space sharing. APFS formatted volumes can grow and shrink inside of a container. So when you partition a disk, typically, you have pre-allocated volumes that are not dynamic, they're not fluid, they're rigid. You have volumes that have set, fixed, pre-allocated amounts of space for your data. However, with APFS, that stuff is very flexible. When you partition a disk, you don't just make a volume, you make a container. And there's volumes inside of the container that can grow and shrink. So let's say I have volume 0 and I keep packing it with data. It'll keep growing, occupying the empty space. But let's say, oh, I want to put volume 1 on here, which I will use to separate some different data and organize my files better. So that's good. I'm now filling up volume 1 and I already have volume 0. But let's say I want to add more to volume 0. Well, guess what? It's not rigid, so that free space isn't wasted. Volume 0 will continue to grow because none of that is pre-allocated inside of the container. So volumes share free space inside of a container, and you actually have some control over how this free space can be used. Inside of Disk Utility in High Sierra, when you create volumes inside of a container, you can set a reserve size and a quota size for each volume. Now, let's try to simplify this with a lot more of a simplistic, kind of real-world example here. So let's say we have this shelf, which is our container, and we have these bins, which are the volumes, and we have these toys, which are the blocks of data inside of the volumes. So we have Timmy's toys and Jimmy's toys. Jimmy likes to collect soccer balls, and Timmy likes to collect these yellow cars. So the space is being used rather efficiently right now, but let's say Jimmy doesn't play much soccer anymore. He gets rid of the soccer balls. Well, now there's all this wasted space in his bin. And Timmy's like, well, now I want to store my toys there. You're not using it. I want to put my toys there. But Mother is like, no, no, no. That's Jimmy's bin. You can't occupy that space, because that's how they're labeled. Well, that's how a typical partition table would work. It's rigid. It's fixed. It's pre-allocated. And it's not that efficient. It's actually very wasteful and cumbersome if you want to have multiple volumes, or in this case, multiple bins, I guess you could say. With APFS, let's say that applies here with space sharing. If Timmy wants to store more toys and Jimmy is cool with giving up his space but not giving up his bin entirely, we could just be like, oh, Timmy's bin magically grows bigger and Jimmy's bin magically grows smaller. So we don't take up any more additional room in the container because these bins are still on the same shelf, but it's fluidly readjusted. It's flexible. It adjusts on the fly, just like how a file system would work. So now Timmy has more space, Jimmy has less space, but Jimmy doesn't need all that space. Timmy needs the space. Nothing goes to waste. So now let's continue talking about some of the other features, but there's one prerequisite we must make sure we understand before we do so. So we're going to talk about cloning and snapshots, but first we must talk about CopyOnWrite, or COW, or cow, moo. So CopyOnWrite, or COW, is an optimization strategy. In APFS, this can help save space, prevent crashes, and boost speed. Sounds pretty awesome, right? And for most people, that's all they need to know. They're happy. But how does this work? Basically, copies of files are only made when changes need to be written. Now, the disclaimer is, CopyOnWrite isn't a magical new technology. The way Apple is using it is rather new to the Apple ecosystem, and they're also introducing some new features which are pretty new to anybody in general, but the technology itself, COW, is not very new. But let's explore the concept. So traditionally, let's say I have mydiary.pages, a pages document, and it's taken up 2 blocks of data on the solid-state drive. Let's say for archival purposes, I need to make a duplicate of this and archive it. So I will duplicate the file. I now have 2 files, and I'm using 4 blocks of data on the SSD. 2 files are using 4 blocks. I'm now using more space, and I also had to use more time and computing power to read and write that data. That's a traditional copy. However, there is a more efficient way to do this, and it's called CopyOnWrite. So now let's say I want to make a copy of that file. I can. Now I have 2 files, but only 2 blocks as opposed to 4. I didn't have to take extra computing power or time to read and write the data, and I didn't have to take up that extra hard drive space. I'm still just referring to those 2 blocks of data, despite me having 2 files. But let's say I need to make a change to the original file that's in my Ken directory. Well, the good news is, those changes can be written out separately in the free space of the SSD as delta files. If one file needs the changes are saved as a delta in a new location. A delta file just means it's a file with changes in it. It doesn't need to duplicate all the data again. It just needs to write out the changes of the data. Let's say I add 2 paragraphs to that giant document. The giant document doesn't need to be duplicated. Just the 2 extra paragraphs need to be saved into a delta file elsewhere in the file system. So it's a lot more efficient. So again, copies of files are only made when changes need to be written. That's the basic concept of CopyOnWrite. So let's say you and your buddies are watching TV. There's 3 people in the room, and you all want to watch House. Well, do you need 3 TVs for 3 people to watch the same show? No, that's wasteful, cumbersome, and inefficient. All 3 of you can reference the same TV while you're watching it, because it's the exact same show. you're all watching the same show. But let's say one of your buddies doesn't want to watch The Magnificent Hugh Laurie, and he wants to watch maybe a more masculine TV show. Well, now we need a second TV because a change took place. The change in this case was a different channel, a different TV program. So now we need that second TV to make space for those changes. So that's a simplistic visual representation of how CopyOnWrite works with files and data inside the file system. So now that we have an understanding of CopyOnWrite technology, let's talk about another APFS feature called cloning. So a cloned file can copy almost instantly, and it takes up no additional space. It just maybe needs to take up a little bit of space for that metadata, because the system still needs to understand where to point to the blocks, and it might need some additional metadata to do that. So that takes up a little extra space, but that's imperceptible to the user. So let's say I make that copy of my diary. It happens immediately, and it's still referring to the same 2 blocks of data like our example before. Cloning copies the references to the data, not the actual data. And again, if we want to make those changes are written out to additional free space on the disk as a delta. They're saved in a new location. So again, we're not occupying all this additional space. We're just occupying the space needed for the changes. And it's very efficient. So there's actually something that goes a little bit further with this CopyOnWrite technology inside of APFS. Snapshots. So snapshots are read-only instances of the file system. Let's say I have my diary, which takes up 2 blocks of data, and a Mac History keynote presentation, which takes up 1 block of data. So I have 2 files taking up 3 blocks of data. Now let's say I take a snapshot with Time Machine, the built-in backup solution in the macOS. This snapshot now has those 3 blocks of data saved in a read-only format, and that's entirely separate from whatever else I do on the system. So let's say I continue making changes to my diary, for example. Again, those changes are written out as a delta in the free space on the SSD. However, even though the changes are written to a new location, that snapshot is still totally preserved. So if something goes wrong, if I make a change I don't want, or maybe I accidentally delete something, I can just roll any of that back. As long as it's in the snapshot, I can roll back to that. And it's all stored on the same drive. Now let's say I delete a file though. Even though it'll look like the file is gone, the file system actually can't reclaim that block that is backed up in the snapshot. If it did, that would kind of defeat the purpose of the backup. Let's say I needed to roll back and get that presentation back. I can do that. If the block was deleted, there would be no way I could roll back. That would defeat the purpose of the snapshot. So the data is still there. That's why if I delete a file, the file system won't reclaim that block from the snapshot because it needs to keep that saved in case of an emergency, in case I need to roll back to it. The cool thing is Time Machine can manage this for us. So Mobile Time Machine will make hourly backups, local snapshots, to the internal drive. And this feature was actually introduced with macOS 10.7 Lion, but there was a 20 megabyte file size limit from what I understand. But now, thanks to CopyOnWrite technology and cloning and the Apple file system, there is no file size limit. And you also won't run out of space by default because the system will automatically know how much disk space you have available, and it will adjust how it takes snapshots. It will delete the old snapshots if you start running out of space. So Time Machine can automatically adjust that so it doesn't suffocate your SSD. But you can also manually delete backups inside of the Time Machine interface should you choose. Now, Apple also has this technology available for developers, so developers could probably also leverage this in a way, but Apple wasn't very specific in their presentations as opposed to how they could. They were actually open to feedback as to how developers could use this technology for making backups or whatever their app would need. So it looks like there's some third-party applications that could leverage this, and there's some opportunity out there. But since this is rather new, I haven't seen anything yet, and I'm expecting Steve Ballmer to just pop up and start screaming anytime now. So now let's talk about Atomic Safe Save. So today, with HFS Plus, this is actually how this would work. Regular files save into a temporary directory during a safe save. So let's say I'm working on this fan fiction and I perform a save. The data is actually stored inside of a temporary folder. And when the data is verified and everything is all good, it all checks out, The old file is removed and the new file is renamed atomically. What do I mean by atomically? An atomic operation means it happens instantaneously. To the end user, it happens so quick. The computer is basically guaranteeing you that the operation is either going to complete successfully or not at all. There is no in between. That's the atomic guarantee. When the data is verified, the rename happens atomically, the file is renamed from temporary to my home directory, and boom, the changes are now there, they're saved, they're official, and it's all safe. And the old data is removed accordingly. So that's all fine and dandy. So what's the issue? Well, the issue happens with document bundles. You've probably seen this before. If you right-click on certain files, it says Show Package Contents. Those are bundles. They're like a folder on steroids. It's truly a folder, but it acts like a single file. It's like in disguise. So a document bundle contains the assets for that file inside of itself. In HFS Plus, when you perform a save, this actually isn't atomic. So because it's not atomic, there's a risk. This is due to a POSIX limitation. POSIX is Portable Operating System Interface. So during a save operation with document bundles, data can actually be lost because this operation can't happen atomically. And the reason is the file is really a folder, like I said earlier. A document bundle is a folder disguised as a file. And since there's assets inside of that folder, the folder isn't empty. So a rename can't occur because there's contents inside of the folder. A rename can only occur if the folder is empty. Again, that's a POSIX limitation. Well, APFS bypasses this POSIX limitation and can atomically perform this swap, keeping the data safer. So if there was a crash or if there was power loss, the data wouldn't be gone because it would happen instantaneously during a safe save. And it does this using a new system call, rename X NP. The NP stands for non-POSIX. So essentially, atomically, in a blink of an eye, this rename can happen and the old data is discarded. And since it's atomic, it'll either happen 100% completely or not at all. There is no in between. There is no wiggle room for failure or for data loss. So those were 4 key features I wanted to discuss, but there are some other nice features in APFS. For example, it now supports 9 quintillion files as opposed to the 4 billion limit. It now has a 1 nanosecond timestamp as opposed to a 1 second timestamp, multi-key encryption, fast directory sizing, sparse files, intelligent defragmentation for hard disk drives, and a boatload of new APIs so developers can implement these features into their applications. So now I have a feeling you probably have some questions, and feel free to ask questions in the comments down below, and let's get a discussion going. But first, I would like to address a few right off the bat. Yes, APFS can be used on a hard disk drive, not just SSDs. You can use it on a hard disk drive as well. APFS can be used on an external disk too. APFS also can work with a RAID system. HFS Plus disks can actually be converted to APFS via disk utility. It's rather simple, and it's all in line. You don't have to remove your data or erase your data or format. It just happens all in place. However, if you want to revert from APFS back to HFS Plus, that will require a reformat, which means you will have to erase the disk. So we covered a brief explanation of APFS and went into the history of HFS Plus. We talked about the benefits, and then we dove deeper into how those benefits are possible. We talked about some quick other features and then addressed some frequently asked questions. So now, resources. Well, if you want to keep learning more about tech products, Macs, PCs, and other software and hardware, I myself actually offer a service called Tidbytes Training. So you can check out tidbytestraining.com, and you can even just leave a comment. If you want to train with me over the internet, let me know. Visit the website or just leave a comment and we can set something up. Because watching the video is great, but you can actually train with me and get my voice over the internet to help you with your tech problems. Or if you just want to learn something new. That's great, and I'm here to help you. But also, there are some other things out there. If you'd like, there's some other links in the description to the Apple WWDC videos that actually talk about APFS, and there's also a guide that has some of this stuff written out in writing officially from Apple as well. So there you have it. That's a quick explanation of the Apple file system. And feel free to check out our other tech videos here on the Computer Clan, and feel free to ask questions down below. Thanks for listening, guys. I hope you learned something, and I'll see you in the not-too-distant future.